PTM 13, 27th dated paper. Question number 26. Which of the following statement about galvanic cell is incorrect? So galvanic cell is a electrochemical cell. In electrochemical cell, anode is represented with negative charge. But here in the first option, anode is positive is given. So this is the incorrect statement. So remaining options all are correct. For cell representation, Cu/U2 plus /Ag plus Ag. Which of the following is correct statement? So here copper is reducing agent. Yes, this is correct statement. Overall cell reaction is Cu plus 2Ag plus gives rise to Cu2 plus 2Ag. So this reaction is also correct representation. Copper is cathode. So here copper is acting as anode. This is a wrong statement. And silver is anode. That is also wrong statement. So first and second are correct. Standard electrode potential for Sn+4/Sn+2 couple is plus 0.15 volts, and that of the chromium 3+/Cr couple is minus 0.74 volts. These two couples in their standard state are connected to make a cell. The cell potential will be, so cell potential can be calculated with formula E cell is equals to E cathode minus E anode. This is the formula. Just substitute the values. So here which one is acting as cathode and which is acting as anode? According to the SRP values, you can say that Sn+4/Sn+2, that means tin is acting as a cathode. So 0.15 minus and minus of 0.74, that is equals to, so here it is 0.89. Second option is correct, plus 0.89. Next, standard reduction potentials of the half reactions are given below. The strongest oxidizing and reducing agents respectively are strongest oxidizing and reducing agents. So whose SRP value is more positive, that is acting as a strongest oxidizing agent. So in the given options, fluorine is having highest positive SRP value, so it is acting as a strong oxidizing agent, whereas iodine is having least SRP value, it is acting as reducing agent. First option is correct. Without losing its concentration, zinc chloride solution cannot be kept in contact with. So more than zinc, which element is there that is more reactive than zinc? Aluminum. So aluminum is the correct answer. Next, 31st. For the galvanic cell Zn/Zn2 plus, concentration is given 0.1 molar, Cu2 plus 1 molar, that is copper. 2 plus copper cell is given. The cell potential increases. Cell potential increases with the increasing concentration of Cu2 plus ions. So this is B. According to Nernst equation, you can say E cell is equals to E naught cell minus 0.059 by N log QC or KC we can write. So here QC, KC values, you can write it as log Zn+2 by Cu+2. So Cu+2 ions increases. Second option is correct. Next, 32nd. The correct order of reduction potentials of the pairs is, so here we have the elements, that is Cl2Cl/ iodine and silver plus Na plus, and E is lithium plus. So if you see the standard reduction potential values of these elements, chlorine is having positive value, that is 1.36, Whereas iodine values, if you see, that is 0.536. Silver has 0.8, whereas sodium has minus 2.714. Lithium has highest value, that is minus 3.045. So least one is which one? Lithium. So highest is chlorine. So the option is first according to SRP values. So we can arrange them. A is greater than C, which is greater than B, then D, then E. Next, 33rd one, that is for the reactions given, Sn2 plus 2 electrons Sn, Sn4 plus 2 electrons tin is given. The electrode potentials are tin plus 2 Sn minus 0.140 volts, and whereas tin plus 4 to tin is 0.010 volts. The magnitude of standard electrode potential for plus 4 to plus 2 is, that is dash into 10 to the power of minus 2 volts, that we have to find out. So to get the last equation, simple, the whatever the first two equations are given, subtract first one with the second. I'll write this, 1 second. So I'll write the reactions here. Given reactions I'm writing. C1's first one is Sn plus 2 to Sn is given. For this 2 electrons are required. So its electrode value is also given, that is E naught of Sn plus 2 slash Sn, that is equals to minus 0.1402. So here I'll write its delta Z naught 1 first reaction. So delta Z naught 1 is equals to minus NF E naught. So here how many electrons are involved? 2 electrons involved. So minus 2 into F into, so E naught value is given, that is minus 0.1402. Its value is, that is equals to 0.280. That is positive value. Same way, second reaction, if you see, Sn plus 4 to Sn. For this conversion, 4 electrons are required. Now let us see, its E naught is given, that is Sn plus 4 Sn is equals to 0. What is the value? 0.10. So its delta Z naught 2 is equals to minus NF E naught. So total electrons involved 4. So minus 4 into F into 0.010, that is equals to minus 0.040 Faradays. So here we have delta Z1 and this is delta Z2. So, and the question is, third reaction is to get Sn plus 4 to Sn plus 2. 2 electrons are required. So this is delta Z naught 3. Okay, now let us see. Delta Z naught 3 is equals to, subtract first equation from second equation. 2 minus 1 we have to solve. So 2 is delta Z naught 2 minus delta Z naught 1. Delta Z naught 2 is given, this is 0.04040 Faradays minus 0.280 Faradays, that is equals to minus 0.320 Faradays. This is delta Z naught 3. Okay, so our reaction is Sn plus 4 to Sn plus 2 plus 2 electrons, that is delta Z naught 3 is equals to minus NF E naught. So delta Z naught 3 value is calculated, that is minus 0.320 Faradays is equals to minus how many electrons? 2 electrons into F into E naught. Minus minus cancel, FF cancel. Then E naught is equals to 0.320 by 2, that is equals to 0.160. So it is equals to 16 into 10 to the power minus 2. So the answer is 16. Next. C is the correct answer. Next. 34th question. Specific conductance of 0.1 molar HNO3 is 6.3 into 10 to the power minus 2 ohm inverse centimeter inverse. The molar conductance of the solution is, so molar conductance formula is lambda m is equals to small k into 1000 by molarity. Substitute all the values. So k is given, that is specific conductance 6.3 into 10 to the power minus 2 into 1000 by concentration is given 0.1. So 0, this point cancel and it becomes 630. C option. Ohm inverse centimeter inverse, sorry, in centimeter square. Next, 35th question. The 35th question we have the resistance of conductivity cell with cell constant 1.14 centimeter inverse containing 0.01 molar KCl at 298 Kelvin is 1500 ohms. Then the molar conductivity of 0.01 molar KCl solution at 298 Kelvin in a Siemens centimeter square mole inverse is. Integer type of question. For this, let us see. Fifth one. So here molar conductance formula, that is lambda m is equals to k into 1000 by molarity. So k we have to find out first. What is k? K is equals to, we have a formula, that is 1 by r into, 1 second, 30. Fifth one. So lambda m is equals to K into 1000 by molarity. So first we have to find out K. What is the formula to find out K? K is nothing but 1 by R into cell constant, that is G star. From where we got this? That is nothing but K is equals to 1 by rho. Rho is equals to what? Rho we can get from where? R. R is equals to rho into L by A. Right? So rho is equals to what now? R by L by A. Now substitute this R value in the above equation, then we can get K value. So here resistance directly given in the question, so direct I'll substitute this in the equation, that is 1 by R is given, the R value is 1500 ohms into cell constant is also given, that is 1.14. So substitute this K value in this equation. So lambda m is equals to 1 by 1500 into 1.14 into 1000 divided by molarity is given, that is equals to 0.001. Right? So by simplifying this, we'll get 760 centimeter square mole inverts. Next, D option is correct. 36th. That is, a weak electrolyte having the limiting equivalent conductance of 400 Siemens centimeter square, equivalent centimeter square, gram equivalent inverts at 298 Kelvin is 2% ionized in its 0.1 normal solution. The resistance of the solution in ohms in an electrolytic cell of cell constant 0.4 centimeters. So at this temperature is, so resistance of the cell is also slightly resistance of the cell we have to find out. Concentration is given, alpha is given, and that is alpha we can calculate by using formula 36th one. No? So once again 36th, alpha is equals to lambda c by lambda naught. We have a formula from this, that is limiting molar conductance. This is limiting molar conductance. Lambda c is equals to alpha into lambda naught, that is nothing but equivalent conductance of the substance. Now let us see. I'll substitute all the values here. 2% is, alpha is 2%, that is 2 by 100 into lambda naught is given in the question, so that 400 ones are 4s are, that is equals to 8. Equivalent conductance at a given concentration C, we got 8. Okay, now let us see equivalent conductance is equals to K into 1000 by normality. This is the formula. So again substitute K value 1 by R into G star cell constant into 1000 by normality. Substitute. So lambda equivalent conductance already we calculated, that is 8. So 8 is equals to 1 by R into G star. G star is nothing but cell constant is given, that is 0.4 into 1000 by normality is also given 0.1. Then R is equals to 0.4 into 1 into 1000 by 8 into 0.1. Then R is equals to 500 ohms. right? Next, question number 37. The amount of electricity that can deposit 108 grams of silver from AgNO3 solution is 108 grams. So 108 grams means it is the atomic weight of silver only. Now let us see AgNO3 solution, where it is 37th, right? So AgNO3 gives Ag, right? That means Ag plus gives this. One many electrons are involved, one electron is involved. So that means 1 Faraday. 1 Faraday is equals to its atomic weight. 1 electron means 1 Faraday. So 1 Faraday is required. Next, 38. Find the charge in coulombs required to convert 0.2 mole of VO3 minus 2 into VO4 minus 3. Here oxidation state of vanadium is 6 and it is 4. And here 8, then it is 5. So what is the change in this? 1. Right? 1 electron means 1 Faraday, you can say. Right? That means 1 Faraday, that is requires 96,500. 1 Faraday is nothing but 1 mole. Then 0.2, how much? X. So that is equals to 0.2. That is equals to 1.93 into 10 to the power 4 coulombs. First option. Next. The volume of oxygen gas liberated at NTP by passing current 9650 coulombs through acidified water is. So water is H2O. It dissociates like oxygen is said O2. So 2 moles we have to take. Then 4H plus 4 electrons are required. Right? That means 4 electrons. Each charge is 9 coulombs is 1 Faraday is equals to 4 Faradays. 4 into 1 Faraday is equals to 96,500. This is equals to what? 1 mole of oxygen is liberated. 1 mole of oxygen is 22.4 liters. Then for 9650, what is the amount of? For 9650, 0.56 liters is required. Okay. See once. This is the answer. 9650. What is the volume of oxygen liberated? That is equals to 0.56. You will get cross multiplication. Okay, 4 into 96,500 gives 22.4. Then 9650 gives how much? That is equals to 0.56. Which one of the following cell can convert chemical energy of hydrogen and oxygen directly into electrical energy? That is fuel cells, right? Using the data given below, find out the strongest oxidizing agent. Strongest oxidizing agent can be calculated by SRP value. So highest SRP value, highest positive SRP has strongest oxidizing agent. In the given options, 0.51 volts is highest. So manganese, that is permanganate, MnO4 minus is the strongest oxidizing agent. Next, 42. The molar conductance of NaCl, HCl and CH3CONA at infinitive dilution are 126.45, 426.16 and 91 Siemens centimeter square mole inverse respectively. The molar conductance of acetic acid at infinitive dilution is. So Kohler's law. According to Kohler's law, let us see. Equivalent conductance at infinitive dilution of acetic acid is equals to sodium acetate plus HCl minus NaCl. just substitute these values. Sodium acetate value is given. Its value is 91, plus HCl value is also given, that is 426.16 minus 126.45. so if you simplify this, you will get 390.71 Siemens centimeters, that is square mole inverse. Okay, next, ionic mobility of which of the following alkali metal ions is lowest when aqueous solution of their salts are put under the electric field? So we know that small size ions are accumulated by many number of water molecules. Its mobility is very low. Lithium. The cell constant of conductivity cell changes with change in electrolyte. No. Change with change of concentration of electrolyte. That is also wrong. Changes with temperature. This is also wrong. Remains constant for a cell. It is always constant. Conductivity cell constant of conductivity cell is always constant. Next. Which cell measures standard electrode potential of copper electrode? So in this, whatever the potential values are given, that is left side and right side both should be unity, same. So that is C option. One, that is nothing but 1 molar, 1 molar, 1 bar. Next, 46th question. That is, the number of Faradays required to produce 20 grams of calcium from molten CaCl2. Atomic mass of calcium is given. Now let us see. CaCl2 dissociates like Ca2 plus 2Cl minus. That means Ca can be converted to Ca2 plus 2 electrons. That means 2 electrons means 2 Faradays, right? Electron required to produce 40 grams, but for 20 grams how many Faradays are required? Half, 1 Faraday. So 1 Faraday is the answer. Next, a solution of Fe2SO4 taken thrice is electrolyzed for X minutes with a current of 1.5 amperes to deposit 0.3482 grams of iron. The value of X is nearest. So let us see here. Fe2SO4 taken thrice, that means oxidation state of iron is +3. Here only I'll write oxidation state of iron is +3. Now let us see. To deposit 1 mole of iron, number of electrons required 3. That means 3 Faradays you can say. 3 Faradays, right, required for 1 mole. For 1 mole of iron. So 1 mole of iron is nothing but 56 grams, right? 56 grams to produce 3 Faradays, 96,500 is required for 0.3482 grams. 0.3482 grams. How many Faradays are required? So if you simplify this, X is equals to 3 into 96,500 into 0.3482 by 56, right? If you simplify this, you will get 1800 coulombs. So according to first law of the Faradays, you know that amount of substance deposited is equals to quantity of current passed through the electrolyte. So in the question time is asking, so Q is equals to, we have a formula that is I into T, right? So here, what is Q, what is I, and what is T, this you know, right? So T is nothing but time that you have to calculate. Then time T is equals to Q by I we can write, right? Q by I. So what is Q? It is 1800 by what is 1.5 amperes we give, right? So let us see, 1800 by 1.5, right? So Q is equals to 1800 by 1.5, that is equals to 1200 we got. Okay, 1200, this is in seconds time, but in the question minutes we have to convert. Then in minutes, T in minutes is equals to 20 minutes. Okay, so 20 minutes. Next, a silver cup is plated with silver by passing 96,500 coulombs of electricity. The amount of silver deposited is. So here simple, silver plate Ag plus deposits Ag. How many electrons? One electron is required. Got it? One electron is required means 1 Faraday. That means 1 Faraday is equals to 96,500 coulombs requires produces 108 grams. So answer is 108. 1 coulomb, that is 1 electron deposited 1 mole of Ag. 1 mole of Ag weight is 108 grams. Next, let us see 49. Weak electrolyte having the limiting equivalent conductance of 400 Siemens centimeter square equivalent inwards at 298 Kelvin is 2% ionized in its 0.1 solution. The resistance of this solution in ohms in an electrolytic cell, cell constant is given 0.4 centimeter inwards at this temperature is. So 49, I'll explain here. Already we did this. Alpha is equals to same formula, lambda C by lambda naught. Lambda C is equals to, lambda C is equals to alpha into lambda naught. Alpha is again here how much percentage? 2% he said. So 2 by 100 into what is the equivalent conductance? 400. So that is equals to what we got? 8 we got, right? So here onwards again same formula, that is lambda C is equals to 1 by R into G star into 1000 by what is this normality? 0.1 normality is given, then N. Substitute all the values. 1 by resistance is given. The resistance of this solution is, the resistance we have to find out, right? Then R is equals to lambda C into G star into 1000 by normality. So that is 1 by 8 into cell constant is given 0.4 into 1000 by normality of the solution is 0.1. If you simplify this, you will get 500 ohms. Repeated this question. Next, take it. Anyways, we completed this. So I'll erase this, and at the same place I'll write 50th question. The resistance of 0.01 normal solution of electrolyte was found to be 220 ohms at 298 Kelvin using conductivity cell with the cell constant 0.88 centimeter inwards. The value of equivalent conductance of solution is. So again the formula is lambda equivalent is equals to K into 1000 by normality. So K value again, what is the K value for this? You know, that is K is equals to 1 by R into G star, right? 1 by R into G star. So substitute lambda equivalent is equals to 1 by R into Z star into 1000 by normality. So that is equals to 1 by resistance is given for this, that is 220 into G star cell constant is given 0.88 into 1000 by normality is 0.01, right? 0.01. And simplifying this, we get 400 ohm inverts. We can write mho centimeter square equivalent inverts. So this is the answer. Thank you.